Right, so in green. Okay, so we all should know what e to the x is. That's not a problem. We've already done that. Now, the log e of x is just its image. It's reciprocal. It's a image in the line y equals x. Okay, it does have an asymptote at x equals 0. Okay, at the moment, that's just the plain log e of x. We write log e as natural log. So whether you see log e of x or whether you see natural log, it's exactly the same thing. Nothing is different. Okay, so be aware of that. In the calculator, don't use log e. Use the natural log when you're graphing, because log e will ask you for a slider, and we don't want a slider. We just want to use that natural log. Okay, so these two are reciprocals of each other, mirror images in the line y equals x. The domain we can see is only the reals positive, okay, excluding the 0. There is no 0. 0 is the asymptote. The range we can see that it is all the all real values, okay, and it's all written there. Any questions so far? Okay. Of course, we will have, dilations, we're going to have translations and all that. So we have to be able to graph these as well. Okay. The first one, okay. I've already said this to you, the vertical asymptote at x equals 0. There's no horizontal asymptote, and the range is all reals or negative infinity to infinity. It's up to you how you want to write it. It doesn't really matter. But the first one says sketch the graph of 3 log e of 2x. Okay, really, this one here, we're not going to see any changes unless we graph more than one on the axes. It's a log e, so it's going to have an asymptote, x equals 0, and the graph will come close to the asymptote, but it will never touch. And this is that graph there, y equals 3 log e of 2x. Of course, we do need to find where it crosses the x-axis. So we know for the x-intercept, we're going to put y equal to 0. And we're going to get 0 equals 3 log e of 2x. So we get 0 equals log e of 2x. So e to the power of 0, just e to the power of 0, or equal to 2x. E to the power of 0, of course, is 1, so that equals 2x, so x will equal a half. So this is a half and 0. So make sure we show that as well. Any questions on example 16? Okay, example 17. Example 17, we have negative log e of 3 minus 2x. So I'm going to do them in stages, but really I can already see that the asymptote here is going to be when 3 minus 2x equals 0. So when I solve 3 minus 2x equals 0, I get x equals to 3 on 2. So there's my asymptote straight away. And I can work out where it's going to cross the x-axis because I put y equal to 0. So I get y equals 0, and I'll do that all for you. Y equals to 0. I get 0 equals log e of 3 minus 2x. E to the power of 0 is going to be 1, is 3 minus 2x, minus 2 is going to be minus 2x, and x will equal 1. So I get my 1 and 0 there. And of course, x equals 0. But to get to this stage, before we know how this graph looks like, that's more important. So let me come over here, and I'm going to sort of squash this in. This is my y equal to the 2x is in part example 16. This is going to be my 3 minus 2x. It's going to be reflected. So I'm doing log e of 3 negative 2x, because the negative is the most important thing at the moment, and that reflects it in that line. So I'm going to get this. Still going to have the asymptote at 3 on 2. And then I've got this negative as well out the front. Okay, so this negative at the front, remember, that one flips it in this line. The y equals 0. So when I flip it like this, it's going to come like that. So I'm still going to have the asymptote of 3 on 2. I now know that crosses at x equals to 1. So that one there is 1 and 0. And I need to find the y-axis. So x equals to 0. And I get y equals negative. Hang on a sec, guys. Sorry. Y equals negative log e of 3. So that's how I get the x, the y-intercept there. The domain, it asks for the domain here. The domain, as we can see now that we've graphed it, it's going to be up to 3 on 2 and all the negatives. So negative infinity to 3 on 2, not inclusive, because 3 and 2 is an asymptote. Questions there? All right, I will clear this. Okay, this one is question 2C from your exercise. It says sketch the graph of y equals 2 log e of x plus 1 minus 1 and state the implied domain. Okay, so we can quickly see here that the asymptote is going to be at x plus 1 equal to 0. So when we put x plus 1 equals to 0, we're going to get x equals negative 1. So there's our asymptote. You can see that straight away. Yes, we've got a dilation factor of 2. Again, you won't see this dilation factor unless you get another graph on there, okay? But we also have a translation. Not only is that an asymptote, okay, it translates it to that at x equals negative 1. And we also have another translation here of y equals negative 1. So the graph is shifted 1 unit left along the x-axis, negative direction of the x-axis. There it is there. And it's also shifted 1 unit in the negative direction of the y-axis. Okay, so really the log graph, which is like this, is going to be 1 unit that way and 1 unit that way. So we can see, and we can put in a point, but we can see it's going to be something like this. Now, of course, always find your x and y intercepts, because that will show you where it's going to cross, because we know it's going to move that and that way. It's going to cross somewhere here. It's going to cross. Whereabouts, I don't know exactly where, but it's going to cross. Sorry, guys, hang on a second. Get out, guys. Out. Come on, out. Can you guys hear me there? Sorry, the dog keeps coming in and out. Okay, so x-intercept, we put y equal to 0. And of course, at the same time, I'm going to move this negative 1 to the other side and it becomes positive 1. That's how I get this positive 1 here. Divide by 2, I get my half, e to the power of a half. To get rid of this log e, I've got to do e to the power. And then subtract my 1. So there's my x-intercept. Y-intercept, put my x equal to 0. So we get 2 log e of 0 plus 1. So it's 2 log e of 1 minus the 1. Don't try and work it out if you don't have a calculator. Just keep it like that. So that one there, we would be writing as 0, 2 log e of 1 minus 1. And this one here, what's log e of 1?
0.
0. So this is 0. So really my answer should be y equals negative 1. I was realizing as I was writing it. Right, so the answer is negative 1. So this is negative 0, negative 1. And the other one, keep it as e to the power of a half minus 1 and 0. Keep it like that. Any questions there? Okay, there is a change of base rules. So if we have exponential and log graphs with change of base rules, okay, I've never seen it on the exam. I'm only showing you because the book has it, or else I wouldn't even be showing you. So really, we can write this. Oops, got to annotate it. We can write this y equals log a of x like this. Okay, where we've got log b of x divided by log b of a. And I'm just showing you about the reciprocal if you have a base. Okay, so if you've got a log base x of y, we can change these two around by doing the reciprocal. So it becomes 1 divided by log y of x. And that might be important in some things. So if we're doing this, and I'm going back to this one here, this graph here, okay, we can get log b of x, this graph, by doing a dilation factor of 1 divided by b over a. Because when we look at this, this is just 1 divided by that. So that dilation factor multiplied by that will give us that log a of x. Okay. Now, that's not as important as this other one, because this other one we're going to use as well. So if we've got, but using inverse properties, we can see, we can do this. If we've got a equal to b log b of a, that's the same rule. This and this are equal to each other because the b and the log b just equal 1. Okay, 1 times a is a. Now, I'm going to put it to the power of x. So I get a to the power of x equals b log b of a times x. And therefore, this graph can be obtained from this log b of x by doing this dilation factor from the y-axis. Now here's how we're going to use this one. Okay, so I'm highlighting these because I'm pointing them out on purpose for you. Example 19 says find the transformation that takes, let me get rid of that email, that takes the graph of y equals 2 to the power of x to the graph of y equals e to the power of x. Now you can see these are change of base. We've got a base 2 here and a base e here. So we're going to use this rule here. Okay, so we'll start off with e. Now e is just, because this is base e and this is base 2. So e, I'm going to write it, I want it as a base 2, but to get it as a base 2, I have to do log 2 to the power of e, because that log 2 is just 1, and 1 times e is just equal to e. So does everyone agree with that so far? Now we have these x's as powers as well. So all I'm going to do is put my x here and put my x here, but I've got to keep that all in brackets. So there we go, put it in bracket, which is what I've got there. E to the power of x equals 2 log 2e to the x. Okay. Now we can get our dilation factor here. So graph of y e to the x is obtained from this graph under this dilation.